Okay, so today we're going to review another basic foundation of algebra, evaluating variable expressions. So first let's talk about what that actually means. So let's start with an expression, which in algebra is basically a math phrase that does not have an equal sign. It typically shows relationships between different things. What the word evaluate is the action of actually replacing a variable with a number and calculating the solution, which is just fancy for the answer. And variable you should be familiar with, but it is a letter that is used as a placeholder in math. Whether you don't know the number or you're looking to change it and kind of analyze what its action has on the outcome. So again, we're looking at evaluating variable expressions. So we are going to be replacing variables that we see in math phrases that do not have equal signs. So to do that, we're going to substitute the variables in with the given numbers that were identified, and be careful that we keep the operations that are shown in that original problem. So let's just kind of take a look and refresh on how different operations are shown. So here's an operation table, just kind of quickly goes through. Addition is definitely the easiest in subtraction. If you're being asked to add values, you're going to simply see an addition sign. If you're asked to subtract values, you're going to see a subtraction sign. Multiplication and division can be shown a couple different ways. So just to kind of remind you, we can have the traditional good old X. Typically, this is seen more in younger years of math, but you will see it occasionally in some algebra problems. A dot also represents multiplying. Sometimes you might see it as like a little asterisk that also represents multiplying. Letters that are right up against each other, buddied up next to each other, those are multiplication. And lastly, you can also see parentheses to identify that operation. So whether it's just around one of the terms or in both, those all lead back to this operation of multiplying. Division, same thing. There's a couple different formats. We can use the traditional division sign, or we can kind of make it look like a fraction, whether it is completely horizontal, like the second example, with again, a kind of a slanted line. You may see it look more like traditional fractions. We've talked about how fractions are simply the operation of division, or sometimes on some activities, you may see it look like this. So again, I was just pointing out that those are the different ways you could see the operations, so that you make sure that you're doing the correct order of things when you're working through problems. And last, it's extremely important when you're substituting those variables values in that we keep the original expression intact. So you're simply just taking out the variable and everything else remains the same in the problem. So let's take a look at some examples. So let's look at single variable replacement first. So if I look at my expressions here, I have 16 minus x in the first one, 3n, p cubed, and r plus 4. So each of those, again, are an expression. They do not have an equal sign. And to the right of each of those, it tells us what the value of the variable is. So in number one, it's 16 minus x. So again, I mentioned to you that we're going to rewrite everything first and keep it intact. And instead of that x, I'm going to go ahead and substitute that value of 5. So I'm going to take that 5 and I'm just going to put it where you see that x. So now my problem looks like this, 16 minus 5. And again, go ahead and grab a calculator. There is the calculator app on your computer that you're given. These are basic computations. There might be a couple roots and we'll have to talk about those. But as far as basic operations, you can just use your calculator. So for this first one, you plug in the value of 5, you should get 11. The second one, we have 3n, and we talked about how when things are buddied up right next to each other, that is the multiplication. So if we would just write 3 and replace my n with 11, notice how I lose that operation of multiplying. So however you choose to write it, you could write 3 with a dot in between. You could write it with parentheses. However you choose to write it, as long as it represents multiplying, is completely okay. It's your preference. So 3 times 11, again, whether you want to grab a calculator and plug that in, or you could do some mental math, either again is fine. So for the second one, 33 for. Okay, this third one, p cubed. So again, I'm taking out my variable and I'm replacing it with the value of 2. So that would be 2 cubed. Now, as far as calculating this, you could realize the function of an exponent means to repeatedly multiply. So this would be 2 times 2 times 2. That is what that means. However, If you get into larger exponents, this can kind of be problematic or just kind of be time consuming. So just to kind of take a look at some options, you might have a caret button on a calculator that you're using. If you have a blue calculator like we use at school, you should be able to find, again, that caret button looks like a mountain, 2 caret button, and then 3, that does kind of in a sense telling you, your calculator, that you're going to raise and make this a little 3. So that could be another option that you could explore in calculating this. If you'd like to explore the calculator app on your computer, you can also choose the scientific option. Switch it over to scientific calculator by using these 3 lines. And this x to the y value is your button that allows you to calculate exponents larger than 2. So to use it, I would hit 2. Again, this is my button, and you can see it actually does put that caret up there, so you know you're using the right button. So 2 raised to the 3rd power, and you should get the solution 8. Okay, and the last one, r plus 4. So I'm taking that r and making it 13. Plus 4 is the rest of my expression there. So 13 plus 4 gives me a solution of 17. Okay, let's take a look at some examples where you were asked to evaluate more than one variable. Process is exactly the same. You just need to make sure that, again, you're just replacing the variable with the values, but also keeping the operation intact from the original problem. So taking a look at the first one, we have the expression xy minus 5. So just looking at that, hopefully you can see that there is multiplication going on between my x and y, and then there is a subtraction of 5. So replacing those variables, x is 5 and y is 2. So again, x is 5, y is 2, and I know that they're multiplying together from my original problem. So you can use your dot, you can use parentheses, again, however you see fit or however you best show multiplication. And then the end of our expression is minus 5, so I'm going to drop that straight down. Then from there, making sure that we're following order of operations, we would do 5 times 2 first, which is 10. 10 minus 5 gives us a final answer of 5. Okay, example number 2, we have r plus s squared. So we actually don't have any known numbers in that expression, but we do know that r is going to stand for 4 and s is 1. So again, we're going to replace those. So 4 is my r value, plus is my original operation, s squared, we have 1 as my value of s, and then we're going to square that value. So again, you do have on most calculators a squared function. Feel free to use that button. So this problem I would enter in as 4 plus 1 squared. And again, however or what calculator you're using, most do have a squared button, whether it be on your phone, the blue calculator from school, the standard calculator. Even if I would change it back to my standard calculator, you do also still have that squared function. So 4 plus 1 squared is going to give you the value of 5. The very last one here, we have r minus s divided by 2. So even though it looks like a fraction, remember guys, fractions are the division operation. So r minus s is on top, and I'm going to go ahead and replace those with the values of 6 for r and s for 2. So I'm going to substitute those in. Remember the action of replacing those variables with numbers. And it is divisible by 2. So this bottom part stays exactly the same. So 6 minus 2 divided by 2. Now here's the thing, guys. If you remember from when we were looking at order of operations, we have to look at groups first. So although division might strike you as becoming the first operation that you should do, we actually have to do what's on top first because this is considered a group. So we would be putting this in a sense in parentheses because we would want to do that first before we divide. We take care of any groupings on the top or the bottom of divisional fractions. So in this case, 6 minus 2 is 4 over 2 divided by 2, however you look at it. And then 4 divided by 2, again, simple mental math, or you can grab a calculator and put that in. And we get the final answer of 2. Okay, guys, so that was a quick review of evaluating expressions. So hopefully this isn't the first time you've practiced this, but I wanted to review some foundational algebra skills in this first unit. So your practice activity is attached, kind of the same situation. You're going over the definitions, and then you're going to practice and show me some problems evaluating single variables and then evaluating expressions that have more than one variable. Good luck and reach out if you need any help.